in this video, I will show you the step-by-step solution of example 2.6 on the topic Thevenin's theorem. Look at the question here. Calculate current IL using Thevenin's theorem. Below is the circuit, and now I will show you how to determine IL by using Thevenin's theorem. Okay, firstly, if you want to use Thevenin theorem, we are going to apply three procedures here. First, we are going to firstly calculate the Thevenin voltage, or we label here as VTH, okay, as our first step. Okay, now to calculate VTH, first of all we have to remove the RL or parts of component that current IL is required. So we throw back the circuit. After we remove RL from the circuit, it will leave two open terminal here. So your VTH is the open circuit terminal here, that is the voltage drop across these two open circuit terminal here. So here we have 12 volt. Okay, and by using your previous knowledge on electrical circuit, so we know that if we open this point, there will be no current flow through resistance 100 ohm here. So therefore VTH here actually is same with the voltage drop across 220 ohm here, and therefore this circuit now from series parallel circuit, it becomes a series circuit because no current will be flowing through 100 ohm. So VTH is equals to voltage drop across 220, which is by applying voltage divider rule. So we have 220 divided by 220 plus 100 here, 100 here, times with the supply is 12 volt. And from this equation, so we get 8.25. So we get here 8.25 volt as the VTH. Now we go to another step, calculate RTH. RTH is the Thevenin resistance. So same as above, we have to draw back the circuit. By now we remove the 12 volt supply and we replace it with short wire, and this point is still open, and by referring at the same reference point, so we can determine our RTH by referring to the open terminal here. So we have here 100 ohm, 220 ohm and 100 ohm here. Therefore you may get your RTH equals to, so start by simplifying the two resistance here first, which is in parallel. So your RTH will be equals to 100 times 220 divided by 100 plus 220 plus with 100 here. That will be in series with the total of total resistance of 100 and 100. So now we can calculate the RTH. So 168.75. So 168.75 ohm. Okay, that is our VTH and RTH. And now the last step to determine the IL that required by the question. So we draw Thevenin equivalent circuit. Thevenin equivalent circuit is the standard circuit where your VTH will be the supplied voltage and RTH will be the internal resistance, which will be arranged in series. So this is RTH, this is VTH. Okay, and then the open terminal here we will place back the RL or 150 ohm resistor where current IL flow through it. Okay, so now we want to calculate IL here. Okay, by referring to the Thevenin equivalent circuit. So RTH is 168.75 ohm. So now we can calculate IL equals to VTH over RTH plus RL. So our VTH is 8.25 divided by RTH 168.75 plus 150. Now here we go. So 168.75 plus 150. Okay, and 8.25 divide the answer. So we get the IL as 25.882 milliampere. 25.882 milliamp. Okay, so let me check back our answer. So VTH is 8.25 volt, RTH is 168.75, and IL is 25.882 milliampere. Okay, that's it. Okay, this is not the only ways that we can implement while we are going to solve this question. Actually, there will be another way or method that you can apply. So I will show you another method to solve this question here. Okay, now we replace with another paper. Okay, using the same methodology. Okay, one, calculate VTH. Okay, so we draw back the circuit, but now instead of we remove only 150 ohm resistor, but here I want to remove both two resistors that is flown by current IL, which is not only 150 ohm, it's actually 100 ohm. Here also is flown by the IL. So we remove both two resistors there. So we only have here 100 ohm here and 220 ohm here. So we have 30. So your VTH now is here, right? Okay, it's actually same with previous solution. So VTH equals to voltage drop across 220 ohm. So we apply voltage divider rule, 220 divided by 220 plus 100 times 12, and we may get 8.25. Okay, it's just same with the first solution. And now second step, calculate RTH. Okay, so calculate RTH. Now we remove 12 volt supply from the circuit and replace it by short wire. Okay, now our drawing will be like this and like this. So this is our RTH. Yeah, refer to these 2 points. So 220 ohm, 100 ohm here. Okay, so by refer to this, so we may get that 100 ohm and 220 ohm actually in parallel. So RTH would be 100 times 220 divided by 100 plus 220. So 68.75. 68.75. A little bit different from the previous solution. Okay, now we apply the last step. Would be the draw Thevenin equivalent circuit with this and this. Okay, so your RTH is 68.75, VTH 8.25. Okay, now at this point we place back the two resistors 100 ohm and 150 ohm here on the open terminal. So we have 100 ohm here, 150 ohm here, and now we can easily calculate IL. IL equals to 8.25 divided by 68.75 plus 100 plus 150. So what we get here is 25.882 milliampere is current, right? So for this solution method, we get VTH as 8.25, same with the previous solution, but RTH will be a little bit different, 68.75, and IL will be 25.82 milliampere. Same with the previous solution. So this is another way you can solve this question. So if you can compare this, you may get the IL same for both two answers. Okay, you can see here. This is IL from the first solution, and this is IL from the second solution. That's all. Thank you.